Hello everyone. So today I'll be taking a seminar on the Langevin equation. So what's over here is the Brownian motion. It is nothing but the random motion of atoms. So the nature of LMS algorithm does not achieve perfect stability or convergence. Instead, it reaches a pseudo equilibrium resembling Brownian motion around the Wiener solution. So the importance of Langevin equation is that it provides a comprehensive explanation for the stochastic behavior observed in non-equilibrium thermodynamics. So let's go through the detailed description of the Langevin equation. The particle dynamics is nothing but the velocity of a macroscopic particle immersed in a viscous fluid is denoted as V of t, and it's influenced significantly by thermal fluctuations. The total force of the particle includes a continuous damping force related to the particle's velocity and a fluctuating force that varies statistically. And the Langevin equation formal expression describes a motion influenced by both deterministic damping and stochastic fluctuations, marking a milestone in non-equilibrium thermodynamics. So this is the equipartition law of thermodynamics. The mean energy of the particle is given by 1 by 2 E of V square T, and it's equal to half of kBT for all continuous time T, where here kB is nothing but the Boltzmann constant and T is the absolute temperature. The capital T is the absolute temperature. The total force exerted on the particle by the molecules in this viscous fluid is made up of two components: a continuous damping force equal to minus V of T in accordance with Stokes' law, where is the coefficient of friction, a fluctuating force F of T, whose properties are specified on the average. The continuation, the equation of motion of particle in the absence of an external force is given by m into derivative of v in terms of t, which is dv by dt, is equal to minus alpha of vt minus f of t. So we'll be dividing both sides of the equation by m, and therefore we'll be getting dv by dt is equal to minus sigma v of t plus tau of t. Here, sigma is equal to alpha by m, since we are dividing both sides by m, and tau of t is equal to f of t by m. The term tau of t is a fluctuating force per unit mass. It is a stochastic force because it depends on the positions of the incredibly large number of atoms constituting the particle, which are in a state of constant and irregular motion. Here, the equation 3.47, which is nothing but dv by dt is equal to minus sigma vt plus tau of t, is called the Langevin equation, and tau of t is called the Langevin force. The Langevin equation, which describes the motion of the particle in the viscous fluid at all times, if its initial conditions are specified, was the first mathematical equation describing the non-equilibrium thermodynamics. So this is all about the Langevin equation. I hope this video was helpful. Thank you.